All right, let's go ahead and put pencils down. Time to start on class today, so I'll go ahead and collect the quizzes. Do we feel like we had enough time to complete the quiz? Yeah? Go ahead and put the quizzes together on the desk. And I need you to get out, what are we on, lesson 9? Go ahead and get out lesson 9, please. Just try not to drop those, please. So, let's see. Grayson, can you read our first objective for us, please? Right, so if we're given an equation, we can solve for a particular variable. Because how many variables are we looking at in our equations now? Say again. Too many? I mean, it's just more than one. I think it's only been 2 at a time so far, so hopefully it's not too many. And Jeremiah, can you read our second objective for us, please? Right, so we need to know what it means when we say to solve for a variable. And we'll wrap up lesson 9 with that discussion today. Did we talk about number 1 from lesson 9 yesterday at all? We did? I know we talked about it in small groups. Did we talk about it as a whole class though? No? Okay. Did we finish working through this number 2 here? Don't know yet? Maybe. Okay, so you only did A here? Okay. Y'all got to D. So some of us are a little bit further along than others. Let's do this. Let's make sure we all have the same correct answer for number 1, writing an equation that represents the weight constraint of a shipment. I think we already have this. And then I'll let you get back to working on number 2, and then number 3 if you're already wrapping up number 2. So looking at number 1, writing an equation that represents the weight constraint of a shipment, right? The cargo ship can only carry 21,600 tons, and the cars each weigh 3.6 tons each, and the trucks weigh 7.5 tons, right? So what are we doing to the total weight of the cars and the total weight of the trucks? So notice I'm not asking for each individual expression, but what am I going to do with those total weights of cars and trucks? I'm going to add them, right? We're looking for the idea of the sum, and that it doesn't quite say it up here, but that's something we need to read into it, that the sum of those 2 weights is no more than what? 21,600 tons, right? And so I want to notice that we're adding those 2 things up. That's how we get one of the most fundamental parts of that equation, right? So, Keon, you prefer a KJ, is that right? Okay, so I'm going to make sure I try to do that. KJ, what's an expression that could represent the total weight of all the cars? What is an expression that could represent just the total weight of all the cars? Nope, I'm just asking, what would go right here to represent the total weight of just the cars?
3.6 cars.
So just 3.6?
Plus 7.5.
So if I'm just looking at the cars?
Oh, just cars.
Is there anything we need to put with that 3.6?
C.
A C, right? And so we need to remember and recognize this because this actually showed up on the quiz today. Why is it 3.6 times C?
Put down how many cars.
That is how much each car weighs, the 3.6 is, but why is it times C?
You don't know how many cars there is.
Okay, so we don't know how many cars it is, so you've explained the 3.6, you've explained the C, but why are they being multiplied? Repeatedly added, right? Every car is adding 3.6 tons to that weight. We don't know how many it is though. We've got to remember, anytime we see that idea of repeated addition, we should be thinking about what? Multiplication, right? So keep that in mind. We're repeatedly adding that 3.6. That's why there's that multiplication. I'm going to keep hitting that time and time and time again. Pay attention to that. So what would represent the trucks, Lexi?
7.5 T.
Right? Each truck weighs 7.5 tons. We multiply by T because we're repeatedly adding that 7.5. And you're supposed to be using that equation, right? One thing I will point out is I saw a lot of students yesterday trying to use like their intuition to figure out how much each of the cars would weigh if we had this many trucks. But I think for those of us that I got to talk to, that was a little bit harder than it had to be. How can I use that equation to figure out how many cars there are if there's 480 trucks?
Plug in the numbers.
Plug in the numbers. So what's that 480 going to take the place of?
T.
T, right? Literally we're saying T is equal to 480. So then 3.6C is equal to, nope, not equal to, plus 7.5 times 480 is equal to 21,600. And I think we talked about it, that the work that y'all did, most of us, without that equation, was exactly the same thing you would do with this equation. The point is that this equation helps you keep track of everything and make sure that you're not making mistakes. Use those equations, they're useful. I will say you might be running out of room if you're doing all this on one sheet of paper. I might get a separate sheet of paper out. Don't forget there's always pencils and there's plenty of paper up here if you need it at the Student Work Center. So that being said, let's get back to numbers 2 and 3. And we'll wrap up after we finish number 3. Maybe. Alright, so let's get to work. Work with those in your group.